And I will quickly move on to our today's agenda. I will set the expectation what we are going to discuss in the next 1 hour. We'll take a short break on top of every hour. So I will try to make sure that we understand each of these concepts very widely. Now, we will introduce you to data science, the problems which are solved by data science, what is data science project lifecycle, what is data science, the types of data and industry applications. Now, how many of you have seen this? Can someone answer what is this? Use the chat window to answer your question. What is this? What can you infer? Bread plus cheese is equals to milk. What does it mean?
Marketing strategy.
Okay, marketing strategy. So what is this strategy?
So when we put all this together, people tend to buy it more. Yeah,
Right.
it tempts them to buy it. If they see them together, they will. It tempts them to buy more. Yeah.
Okay, good. Good answer. Anyone else? Priyanshu, total nutrients in bread and cheese combined is equals to nutrients in one milk carton. Okay, that's one way to look at it. But from a machine learning perspective, marketing strategy,
Like,
right?
if you see Amazon, Flipkart, they also mention like also buy it.
Right,
People are also buying.
right, right. So this is actually how the consumer are, uh, clubbed together. So this is one sort of recommendation, which which basically tells us that people who tend to buy, bread and cheese also tend to buy milk. So you will see that, if you go to a Reliance Trends, I'm sorry, if you go to a Reliance Fresh or Big Bazaar, you'll probably see, milk, cheese, and bread all are together because people tend to buy. This is the buying pattern, right? And at times you'll say that see that um, with months in the same supermarket, the orientation of the particular products have changed. So you will see or the location has changed. So you will see at times milk is with bread, at times milk is with biscuits, and so there are different type of scenarios. And this is what is created by the marketing team by understanding the buying pattern of individuals. And also you will see this keeps on changing with seasons as well, right? So this is something which we need to understand from a type of customer point of view. Now, if someone buys, say for example, iPhone and a beer and a cornflakes, can someone predict what type of customer it will be, as opposed to someone who buys iPhone and a diaper and a beer?
A bachelor.
A bachelor, right? A bachelor is the one who is interested in more buying beers and cornflakes, and then once they are into their parenthood, they will probably buy diapers and iPhone and beer. So this is how we guess the type of customers from their buying pattern. So you can see here that we have single male or female. They will tend to buy beer, cornflakes and iPhone. And then when they're parents, you will have different type of customer behavior. Now, one thing which we can also understand is what else they can buy, right? And what further information I do have, I have, right? So someone who buys the iPhone and a beer and a cornflakes will also buy biscuits, and the probability is 97%. And that is how we come to a conclusion that whenever there is a cornflakes or beer section, you should probably have some stack of biscuits with cornflakes, some stack of biscuits with beers. And at times you will have also seen that in some of the supermarkets, biscuits is not at one place, right? It is actually present in different places. It might be, near the milk section, it might be near the cornflakes section, it might be near tea section, right? So this is how the buying pattern of a customer is, analyzed, and based on that we come to a conclusion and try to uh, create different segments in our retail industry. Now you know that if someone is buying iPhone, diapers and biscuits, the probability of buying a cosmetic is probably 91%. So this is just a scenario, okay? Don't take any real life example from it. Now this is actually something called a recommendation. So we are recommending that a customer can buy based on the buying pattern of other individuals. And 35% of the sales of Amazon is actually generated through recommendation engine. We all know, we are all shopping through Flipkart and Amazon, and we know, and a customer who viewed this item also viewed these products. So this is just a way uh, to recommend certain products, right? Out of 100 per people, if one of them buys, a company can hugely benefit from it, right? Now how far is too far? So you all know, we all know that all these companies are collecting a large amount of data from us, right? They obviously they ask you, what is your phone number. And when in the billing counter, at the billing counter, they will probably ask you what is the phone number, and from that phone number they create a unique identifier, and they create a buying pattern history, right? They create a buying pattern history, and from that they analyze what type of customers are buying what type of product. Probably when you go to the supermarket for the first time, they will ask you your date of birth as well, right? At times I have seen the cashier asking for a for the date of birth, and in case you are not providing that, they probably guess the age and enter it in their system. So this is how they start finding patterns in the data through age and through gender, you know and um, and products are recommended to us and we are not aware of that, right? um, we also know that there are certain products which are present in the cash counter, right? A chloromint, or some biscuits, right? Or some chocolates, and these are high margin products. So if you see some certain products like um, a biscuit, right, which is not that popular, but you will see those biscuits present at the cash counter because these are high margin product, and there is a tendency for the person to buy, okay, let's buy a biscuit, okay, and this will give them high profit. Now, to understand how far is too far, say for example they are collecting a lot of data from you, right? And say for example me and my wife both went to Reliance Fresh, and we bought something, and they are uh, they understood the pattern that my wife is pregnant, and she's probably buying oversized clothes, and she's buying certain items which are required in pregnancy, right? So they might also guess in which trimester she is, and what is the when is the delivery date. So this is something which we can also predict through the data, so that's not a problem. The machine learning has been that far. Now, if someone gets into your privacy, then that's a problem, right? We have these apps in our mobile where it asks for permission because they don't want to play with our privacy. And I don't know about India how strict we are, but in the US or in Western markets, Australia, this is something a very big issue, right? You cannot play with the privacy of the customer. So if all of a sudden your wife has now delivered, and you have a baby in the house, and all of a sudden you open your door and you see a big parcel from say Reliance Fresh, you'll probably freak out, right? Because they have guessed the delivery date, and based on that they have sent a gift to you, and this is something which is too far. So when we create a AI/ML model, it is very important that we are not playing with the privacy concern of customers. So when So now you are studying data science. If you take classes of product management from me, I will also showcase very practical examples where um, we are bound by certain regulations when we develop any AIML product. User privacy and user concern is a major challenge. Okay, and we have to showcase our product to in the information security, and they go through all the risk management analysis. They have certain controls, and based on that we get an approval to launch this product, right? Next is target. So why data mining is such a huge task now? Because in order to get to that particular output of your model, you have to always understand that data is the source from where you can create um, heavy machine learning models, right? Without data you cannot create any data science, machine learning, AI models, right? So target has a specific 60 members team, a data mining 60 members team, where they mine data from different stakeholders, be it third party data vendors, be it crawling the websites, be it getting data from external vendors, right? And they get data for specific type of products or specific type of customers, any type of private data. They target ads, buying behavior. So all this type of data they they get from external vendors. Now what they can create is, if a woman is a shopper is expecting, and what's the approx due date, as I told you in the previous slide, they can guess that. They can predict the income level based on the purchase history, right? They can attract customer attention through custom brand offerings, right? You might have seen that you get an email or SMS specifically targeting you to come to their store and buy something, because they find you a valuable customer in that particular section, right? So all these companies now have dedicated teams which basically mine the data in order to create certain user experiences. Now what is the data? We all know that data is the raw ingredient, right? Without the data we cannot create anything. If you want to cook something, you need a raw ingredient, right? So data is that part. And data can be anything, right? It can be sequence of bits from, say for example, a sensor. It can be a table of number from your CSV file or your SQL table. It can be characters on a page. It can be your annual reports, or your balance sheet, or your resume or CV. And according to that, we can also create any type of data. We can structure that data. Even data from the moon rock specimen is something which scientists use to analyze certain features of planets, right? And that is data. Data can be text, data can be sound, data can be bits, data can be sequences, anything, right? We'll move on to the next one with what is data science. So this is the most important slide which you need to remember, that data science is not only about writing machine learning algorithms, or creating something which nobody else can create. And if you want to create something which nobody else can create, you have to basically understand three parts. One is how to create the solution using a programming language. Either you or your team can create it, right? You or your team should know what is mathematics and the statistics behind your data, right? And your team should be well versed with the domain knowledge. And I will probably say domain knowledge is 50 to 60% in this entire life cycle, because if you don't understand the business, you'll not be able to deliver solutions which will help your end users, right? So computer science and software development in total creates machine learning. And again, machine learning, mathematics and empirical research creates machine learning. And domain knowledge, empirical research, software development is also a part of data science. So we have to understand that computer science, mathematics and statistics, and domain knowledge are the three pillars which are required in order to create a data science solution. Okay. Now, who are data scientists? I have told you earlier that data scientist is someone who is better at statistics than any software engineer, and better at software engineering than any statistician. When this data science concept was not there, we had statisticians, right, who used to look into the data, create models, or it's very simple models. They used to create visualization using their statistical tools like SPSS, for example, right? And but they lack that sense of how to program this further and how to deploy this solution so that the end user can benefit it. Their analysis was more on silos. They were performing ad hoc analysis on their individual laptops or desktops, right? Or in a notebook, right? But since they don't have that um, skill of a software engineer, it was very difficult to productionize this whatever they have created. So for that, a good data scientist should have the knowledge of both software engineering and statistics, right? And domain knowledge is which is very much important when you are a data scientist. Now let's move into some deeper discussion, whether it is arts or science. So if someone's only thinks that data science is only about programming, you should how to write hardcore programming scripts, then you are wrong. It is more of a art and less of a science, right? If you go to any company or any organization, you'll probably see that creating a machine learning model is probably 10 to 15% of the entire Herculean task. Okay, the major part is to understand the data, to process the data, then create a machine learning algorithm, which is the 10 to 15% part. And fourth is how to deploy this. And before that, it is very much important to understand that our stakeholders who are sitting on top of us are non-technical folks, right? My if I give you my example, my immediate supervisor or the senior manager is a chartered accountant. So you can understand that he he's well versed with the data science tools and techniques, and um, all the resources which are required to be a good data scientist. But somehow you have to understand that he is from a non-technical background, and it is very much difficult um, for us from a technical background to convince any non-technical person or a person who are sitting in the governance or management, that what our results are and how it can benefit, right? And so that is more of a art. So you should have the art to convince, you should have the art to convince your stakeholders, right? It so so further to that, ways in which creativity can be expressed in data science include applying techniques in unconventional settings, right? You have to apply techniques in very unconventional settings. Unconventional as in you have never seen this type of data, right? Or this type of solution is not present in Stack Overflow or Google, right? So you have to apply any technique through, we read a lot of research papers. So if you ask me what I personally do day to day, I probably read one or two research paper every week, right? Just to understand uh, how the solution which I'm going to create in the next week or in the next 2 weeks is already implemented in research. So research folks are researching about any particular topic or problem, but they have not created a solution which can be productionized. So you have to apply different techniques. You have to combine techniques in unconventional ways. So there might be different type of techniques. A machine learning algorithm can be a mix of two or three algorithms. It might first use a regression technique, then it can use a classification technique, and then it can use a recommendation technique. So you have to combine these different techniques, develop new and unusual hypotheses. So as we have all known that you know as we know that hypothesis testing is something where you look into data and infer about it, right? So you have to understand the data from new aspect, and you have to create unusual hypothesis. So this is more of a art and less of a science. And this slide is something which you can also skip, but just wanted to show you that why do data scientists get paid a lot? Because we as a data scientist should always understand that our you know output directly impacts the business value, right? And we have organizations nowadays are facing very enormous data challenges, right? We have to procure data from n number of sources, so you cannot have only one data vendor from where you can buy the data or source the data and it will work for you. So you have to have 4 or 5 different vendors. If, for example, I am particularly working with 4 to 5 data vendors, Refinitiv, Factiva, Dow Jones, emerging markets, Crunchbase. So these are type of data vendors who provide data to us. It can be um, financial data, it can be annual reports, it can be earnings report, it can be investor presentation. So when you work with this type of data, you have to have different sources, right? There is a severe shortage of talent. I personally can say that I am interviewing more than 10 to 15 folks every week now, because there's a severe shortage of talent and we want to fill those positions as quickly as possible. And why data scientists are paid a lot? Because now these type of technology is not restricted to any tech giants anymore. So even a startup is using data science and AI ML to a large extent. I will showcase you one case study of Bharat Pay, how they are using AI and machine learning to scale up their uh, products. Now, what differentiates a good data scientist and a great data scientist is effective communication, intellectual curiosity, domain industry knowledge, and analytic problem solving capability. So, as I said, domain knowledge is one of the pillars. Intellectual curiosity, you have to be very curious with your data, what else your data can speak, right? Or what else your data can tell you. This is something which you should have in order to make sure that you are grinding the data very well in order to get to the desired result. You should be very effective with your communication whenever you are talking to your stakeholders, right? um, Try to convince them with your points, because it's very difficult for a data scientist to convince your stakeholder, right? And when you join any organization, this is and if you talk to me after a year, we'll ask this type of question to you: how effective is your communication, and are you facing any challenge to convince your stakeholder? And 90% of you will tell me the same answer, that yes, we are finding it difficult to convince our stakeholders. Okay. And then you should have an analytic problem solving capability. So you should have that um, understanding to how to solve any sort of problem, what type of technique should I prefer, right? The problems that data scientists solve. Okay, whatever I have talked to you is just a brief to give you a guideline of how a data scientist should be, how to make sure that you understand what is the roles and responsibility of a data scientist. Now, the problem that data scientists solve, the first is this A or B, right? Whenever there is a question like whether it's A or B, you should use a classification problem. For example, whether the loan will get approved or not, right? Yes or no. Whether identify this is a human or a dog, yes or no. So you will use a classification problem. It can be A or B or C also, where you will um, find, say, for example, whether this is a dog and a cat and say a cow, right? So it can have uh, different classes. Okay, it can be 2 class, 3 class, 4 class, 5 class, or so on, but it should have a definite number of class, right? Next is this weird? When I said is this weird, I want to say that if there is anything suspicious, is this mail in your inbox spam? So this is anomaly detection, right? Is someone riding bike on a walkway? Obviously you cannot say this in India. In probably some places you might have, but you might say, but in general you should not ride your bike on a walkway, right? So is someone riding bike on a walkway? So this is the anomaly. So the question you should ask yourself is this weird? Next is how much or how many. So regression problem is there to solve, right? Whenever I ask you a question, how much will this car sell for? You will say like $24,000 or $5,000 or $2,000. So your answer is very discrete. That is, it is going to be a number. So how much or how many? Predict how many product sales be achieved in this month. Okay. So you'll probably say I will sell 50 products, or our company will sell 10,000 products. So you have a definite answer, and in there you will use a regression. Next is, how is this organized, right? When you talk about the the clusters, how this is organized. So you use a clustering algorithm. What viewers like the same kind of movies, which pet owner groups have the same purchase behavior for pet foods, right? So you're clustering the data. So for example, you have 100 customers and you want to cluster them into three parts. Someone buying more than 60 dollars a week, someone less than $60, and someone not even buying anything from your shop, right? So you are clustering your data. So this is how it is organized. Next is, how should I do? What should I do now? So whenever you see a robot, right, a robot will take guidance from its own algorithm, okay, and it takes steps. So when we'll talk about reinforcement learning, we'll make sure that you understand that these all work um, on a system of reinforcement learning, where we are reinforcing the robot in case it is making a mistake. So we are penalizing it if it case it makes a mistake, and we are rewarding it if it is taking the correct step. So this is how we were trained from our childhood, right? So whenever we did something wrong, our father or our parents would make sure that they penalize us either anyway. Probably you cannot go to the picnic, or you cannot go to play today. So we are penalizing them for any wrong action, and we are rewarding them for any correct action. Say for example, we did good in our maths exam, and we were rewarded with, say, chocolate or something else. So this is how a reinforcement learning work. So what should I do now? So if this is type of question, then we have a reinforcement learning. Reinforcement learning is also used in self-driving cars. Should I brake, accelerator, or continue at the yellow light, right? So the car takes a decision based on reinforcement learning. So if it sees a red light, it knows that it is the model is going to penalize, right? So it will not move. When it is orange, probably it will start the car, and if it is green, it will probably accelerate. So this is how these were some of the problems which can be solved through machine learning. Now, industry application, we'll quickly look into the industry application. It can be used in telecom, where we can uh, predict which customers are going to churn in the near future. We can create customer acquisition strategies. We can upsell or cross sell our products, right? It is also used in pharma industry, where we do A/B testing, we do genetic analysis, we do clinical trials using AI/ML. Next is the finance industry. It is heavily used in finance industry. I would say AI/ML is probably researched a lot in finance industry now. So you can find financial fraud. You can do algorithmic trading. We call algo trading as well. We can do personalized services, right? Identify portfolio risk. So this is all what we can do in finance industry. Next is in banking and finance. So in banking, you can find out fraud if there is any fraud going on in your product, right? And we can do customer segmentation in order to target customers for any banking products you want to sell. You can do risk management to analyze whether you should give loan to that particular individual or particular company. You can do portfolio optimization to make sure that all your stocks or bonds or hedge funds are diversified, and you're optimizing your portfolio using AI/ML rather than a fund manager looking into it. Next is, it is used in electricity, energy, and utilities, just to make sure that we are using AI/ML heavily in the maintenance of machineries. Identify any theft or loss prevention, churn analysis, and auto balancing resources and dynamic routing. So these are some of the applications in the energy sector. In manufacturing, we are using it, custom design product, better quality assurance, because there is a AI monitor who basically looks into the product quality, and there is any problem with the quality, it automatically filters them out. Next is improving the manufacturing process, managing the supply chain risk. And with that, we'll quickly move on to the data science process. And this is how it is. So we have to understand that we will never get the data in a CSV file when we work in an actual project. You have to basically, fetch the data from different sources. You might have a data team who will provide you data, or if you work for a very small organization, or even in a big organization, you're part of a very small, horizontal or vertical. um, you have to collect your own data and process it, right? You can collect the data from external data vendors. So these external data vendors provide you data through API. So you can write a Python code to fetch the data through API. I will show you one example at the end of this course at how to fetch data from API. And once that data is collected, it will either be in an XML or a JSON format, and then you structure it to a CSV format and store it somewhere. And from that CSV file, or from that flat file, or or whatever format you have, you will try to create your machine learning algorithm on top of it. And then you have to deploy your model. You have to communicate your result to the end user, make some decision, and then you will deploy this to your end user for real-time access. So this is how a data science project look like. I will go through more of it in the subsequent slides. Don't worry about it if it is looking too complex to you. Now, the steps which we need to follow in order to uh, create a machine learning algorithm is, we have to collect the raw data. As I said, we will be collecting the raw data from, different sources. Sometimes your organization may already have data, right? Sometimes it might not have the data, right? At times you have to work with the data engineers, the data infrastructure team to build and start collecting your data. And at times, if you are an individual contributor, I have worked for 3-4 years as an individual contributor, and I have to write my own script in order to fetch the data. Okay. Now, next step is to store the data. You can store the data anywhere. Okay. If it is a very structured data, you can store it in a SQL database, right? But if it is a unstructured data and a huge volume of data, probably you need a data lake or data warehouse, right? It can be supported by big data applications as well. We'll come to that later. So the step 2 is store the raw data. Next up is the data pre-processing. So once you get the data, as a data scientist, your time will eventually go in cleaning the data, right? And what type of cleaning you have to do? You have to remove any type of outliers. You have to remove missing values, or impute these missing values. If there is any malicious data or garbage data, you have error, you have irrelevant data, inconsistent data, and formatting. So all of these we have to perform, and we will also do this as part of EDA of all the machine learning process. So instead of taking different or a separate class for EDA, I thought of including EDA with the machine learning process, because uh, with that you will get a real picture of what is EDA all about in machine learning. And if I go through EDA in a separate class, it will be very boring and you will feel very disconnected with the actual end goal. Okay. Next is you have to perform your pre-processing of the data. So you will have a dirty data set or an unclean data set, and you'll convert this to a clean data set, right? So when you say it is unclean, it means you have the data which is not standardized, you have missing data, you have duplicates, right? And with that, we will basically, once you create the data which is clean, you have to process it so that it is ready for use. Okay. At times, ready for use means you have to create certain columns which you need. For example, if you have a date of birth, you have to calculate the age from the current date, and based on that you perform analysis, right? So these are the type of things which you need to perform. You have to perform sorting of the data, summarization, aggregation, validation, classification, right? So these are all the steps we need to perform in order to create a machine learning algorithm. Now, what happens is that you have input data, you have processed it, and you have the output data. So this is just an example to show you how the processing works. Now, as we know, we have to do EDA, and one part of the EDA we have already talked about in statistics is you have the entire population, you take out certain sample, and you perform some EDA on top of it, and then you infer about the entire population, right? In EDA, we will basically spot any anomalies. We will frame our hypothesis. We'll check our assumption, right? We'll find out the mean, median, outlier, spread, correlation, hypothesis, everything. Okay. Now, once that is done, we will create our models and algorithms. And this is where, data science is very exciting. But I just want to set the expectation that whenever you work in a live project, this part is going to be of 2 or 3 weeks. Rather, entire time of yours will go to data cleaning and working with different teams to understand the business and data models, right? So don't be in an assumption that if you be a data scientist or you're a data engineer, you'll only do that type of tasks. So for example, if you're a data scientist, your roles and responsibility will not only include creating data science models, but um, performing tasks which are more of data cleaning and data analysis. Okay, once you have created the model, you have to communicate and visualize this to your stakeholder, right? Your stakeholders should understand and should be um, present with you in order to make sure that if there is any changes which is required, right? Because at times these stakeholders are or management folks or your manager or your senior manager or your functional manager, they are working on this process for 20-25 years now, and they have certain intuition. It says, okay, so you have used this column to analyze your data, but we think that this column is of no use, right? Say for example, if you want to predict the temperature of a certain place, and if you have used something like a humidity, right? It might be useful, it might not be useful, but just hypothetically think that if your um, stakeholder says that uh, our statistical understanding or our intuition says that humidity is not required in order to predict the temperature, they might have some intuition behind it, and you should also have a certain level of confidence why you are using this particular column of humidity. So you have to brainstorm with your management and showcase the benefit, and and then you have to analyze the models and bring this to the plate, right? And you have to also seek the uh, management's consideration if you want to deploy the solution to real world to help make the business more optimized and beneficial. Right. The next we'll look into the types of data. We have structured data, we have the semi-structured data, unstructured data, and then we have graph and streaming data as well. So ideally, there are 3 types of data, which is the first 3. One is the structured data. Structured data is something which is present in a very structured manner. When we say structured, it is present in a row and a column value, right? So if you have an Excel file with numerical data or textual data, which has certain rows and certain columns in a very predefined structured manner, we call it a structured data. When we have a semi-structured data like a JSON file, where you have data in a key value pair, right? Or we have log server data. In that case, it is semi-structured. And when we say unstructured data is like videos and images and data which are coming to be very unstructured. You don't know like how to structure them, right? So this is an unstructured. We'll come to the definition in the later part of the curriculum. And then you have graph data. If you have created something related to um, graphical analysis or network analysis, you have graph data. But generally, when we say types of data, we have structured data, semi-structured data, and unstructured data. Now, coming to the data, we have 2 types of data. One is qualitative and quantitative. Qualitative is something which tells the quality, right? Whether it's a green or blue, whether it's a small or big. And when we say quantitative, you have a quantity, whether it is 2 or 3 or 5. If it is score, it is 85, right? 67. So there are two types of data. Now the data quality issues which we generally face is duplicity. If we have duplicates in the data, if we have inconsistency in the data. Say for example, if you have a column and in the column age, instead of having a numerical value, you have say gender, right? So this is inconsistent, right? Correctness, you should have a correctness in the data. Should have a timeliness in the data. For example, if you are fetching, the customer records of a particular outlet, you should have data for each and every date. So you have timeliness of the data. Missing values, so you should impute the missing values, because when we use a data in a machine learning algorithm, we want to make sure that there is no missing value in the data set, right? So with that, we complete our small intro to machine learning data science. If you have any question, do let me know or use the chat box. Try to go a little fast because these are the things which we'll talk about every day. Okay, so I will share the slides with you also. If you have any question, do let me know. I hope it is all clear.